Welcome to this web-exclusive edition of PDC 2008. My name is Uday Shivaswamy. I'm a program manager at Microsoft working on application compatibility. I'm here today to talk to you about building better compatible applications for Windows 7. So what do I mean by that? What I mean by that is two specific things. One, how do you get your apps designed for XP and Vista to work on Windows 7? And secondly, how do you get your applications to be designed in such a way that these applications can work fine on future operating systems? So what is the key takeaway for you from this session? Two things I want you guys to know by the time you go through this session. One, what are the resources available for you to figure out what you need to do to get your applications to be designed for Windows 7? Two, what are the topics that you need to be concerned about to get your applications, again, working across the board over multiple releases of operating systems? So with that in mind, let me give you a little bit of background on why application compatibility is actually important. One of the largest feedbacks from the Windows Vista release and the lessons learned was that application compatibility was one of the top 3 blocking issues for both enterprises and for end-user customers for deployment scenarios and for upgrade scenarios. So obviously, the things that are keen for end users are applications need to just work when they buy new machines. For enterprises, the IT administrators need to be confident that they will be able to deploy a new operating systems with the large set of apps that they have without having to worry about compatibility issues. And thirdly, for developers, the better the apps are designed, the easier it is for you guys to migrate them to the new versions of the operating system. At the outset, I want to say that applications that are designed for Vista are highly compatible with Windows 7, and there's very little work for you guys to do. However, apps that are designed for XP need to come up to speed to the Vista design and architecture. With that in mind, let me just give you a background on what are the kinds of compatibility issues that we see at Microsoft. I divide these into 3 different areas. One is applications that use private structures and functions. And secondly, things that we make changes to the operating system knowingly. And thirdly, there are changes in the operating systems that hinder the application's experience, but not necessarily break them. Let me go back and give you a little bit more details on the 3 of them. Applications tend to use private structures, private data types, and take dependencies on specific things like load order of DLLs during boot time or certain registry values that are private to Windows. These are subject to change over the releases of the operating systems, and what this does is that when an application is tied to that, they tend to break release over release. And the second the second category is applications tend to take dependencies on the OS version number, for example. Applications that always check version numbers and break because of that are the largest bucket of failures for application compatibility we have today. And thirdly, things such as Windows Mail and high DPI in Windows 7 are things that are changes that will hinder a user's experience or an application's experience, but doesn't necessarily cause problems. So let me step back a little bit and say what we actually do to ensure that compatibility is really high when we release an operating system. First of all, we have multi-pronged approach towards how we deal with that. To begin with, we do design reviews in a proactive way. All the features that are scheduled for an OS version is reviewed for compatibility, and broad mitigations or solutions are found and applied to in such a way that applications don't have to go through a lot of pain to migrate to the new features. Secondly, we do proactive testing. We test thousands of applications in Windows and make sure that these applications are working. And any bugs that we find using these applications are, again, reactively pushed through, and we work with the feature teams across Windows to make sure that they're working. And thirdly, we have a large partner outreach program that I will talk to you later, where developers and ISVs and enterprises can contact us and work with us to make sure that the applications are designed properly so that they can move forward and be compatible with Windows 7. We also have mitigation strategies for applications that are broken for various reasons that I already talked about earlier. One of them is provide individual fixes for unique applications, where we have fixes that are broken, fixes that are applied to broken applications which are very specific to that particular application. We also have a new opt-in behavior in Windows 7 where you can get a class of applications to be selected into a certain behavior in an API. For example, a new change in an API in Windows 7 may cause an application behavior change. However, if an application is aware of that change, it can opt in to that change. If it's not aware, it will get the legacy behavior. So these are kind of the approaches that we have for ensuring compatibility. All right, so before I dig into individual topics, I want to talk a little bit about the resources that are available for you. First of all, there's a compatibility lab at the PDC where you are. So you can take your applications, go to the lab, get them tested on Windows 7, and see how they perform. And along with the disk that you get the application quality cookbook. This is a wealth of information that you can get, that you can use to go through details of the topic and read more details on the white papers that are available on every topic. Then get ready for the Logo program. The Logo is an enhanced program for Windows 7, and you'll see a lot of interesting things there. There's also a website called devreadiness.org. This is a purely developer-centric website which tells you about a lot of topics on Windows 7 and Windows Vista and how to get your applications compatible with these platforms. Lastly, there's the Windows Compatibility Center. This is an end-user-facing website which was released recently, where end users can go check their applications and devices to see if they're compatible with their operating system. The reason why I'm bringing it up here is that as developers and ISVs, you can contact us to see if you want to list your applications and devices as compatible in this website. So with that in mind, let me go in and start talking about individual topics in Windows 7. The topics that I cover today are three major ones: the OS version check, the Windows mail, and security applications, and then provide guidance on various other features that have changes in Windows 7 and that might impact applications. With that in mind, let me go do a quick demo of how an end user experiences the adverse impact of the OS version check. I have a small application here which is essentially running a version check on the application. The first time I launch an application, what the end user is going to see is their application failed. And this, right at the outset, has a broken scenario where the user cannot either install their application or they cannot apply any future productivity with this application. However, there are many facilities in Windows where the user can bypass this setting. So I can go here, right-click on the application, and use the troubleshoot compatibility feature in Windows. What this allows the end user to do is essentially bypass that particular OS version check and get back to getting their applications working properly. So why am I saying this? While this is going on, let me go talk to you about the OS version check itself. OS version check is one of the largest categories of application failures that we have. Checking an OS version essentially means that you're ensuring incompatibility. So this is not a good sign. And users have many ways of working around it. And this is also one of the reasons for not getting the logo. One of the things in the logo program clearly states that you cannot check OS version. So if you really need to check the OS version, do it as a greater than or equal to, so that you make sure that you tend to work for future generations of Windows operating systems. All right, this is the demo that came back again. So at the outset, you will realize that Windows 7 is version 6.1 and not 7.0. The reason for that is, again, compatibility, because when applications check for major version numbers, they make sure that they are incompatible. Because of that, when we reduce the version, keep the major version number to 6, you don't have the problems with a majority of the applications. However, there's a small exception to this rule, and that exception is only for applications that do security, backup, and firewall kind of scenarios. These are the only applications that are really strongly tied to applications and need to be able to work well with every application that's out there. With that in mind, let's move on to the next topic. The next one is Windows Mail. Windows Mail in Win 7 is deprecated. What does that mean? Many of the APIs are disabled. Many of the entry points are not supported. Protocol handlers will not be associated, and file associations will not work with Windows Mail. However, most of the applications that use the default mail handler will not have any problem. The problem comes in when applications take hard dependencies on things like winmail.exe or use the Outlook Express APIs, which have been deprecated since Windows Vista. So there are still some applications that use that. So with that in mind, the clear goal here is if you already use a default mail handler, you don't have a problem. It will be straightforward for you to move to Windows 7. However, if you do take dependencies on Outlook Express or winmail.exe in specifically, then that is the point you have to start moving and thinking about changing your code to use the default mail handler. All right, let me go to the final part of the three topics that I need to cover for Windows 7 compatibility breaks. And these are for developers and ISVs who do low-level applications such as security, antivirus, firewall, and backup. If you are one of those developers, please contact us. Microsoft works with them on a regular basis for every operating system version. If you're not already contacted by us or if you're not already engaged with us, here's the email address where you can contact us. We will work with you. There are many Microsoft consultants that are available that can help you debug your applications and come up to speed for Windows 7. These are the only apps that really need to be deeply involved at an operating system version check level and make sure that they come up to speed on Windows 7. So with that in mind, let me move on to more specific guidance around various topics for Windows 7. First of all, I'll start with the new IE 8. Windows 7 comes with IE 8. And the version check issue for IE 8 is the user agent string. User agent string is a string that comes with IE, which is essentially where you can do a browser check, where developers do browser checks. And the string comes with MSIE 7.0 for IE 7. Obviously, that's been updated to MSIE 8.0. However, IE 8 comes with its own compatibility mode, which is the IE 7 mode. So what does that mean? When, by default, all internet sites will run in a compatibility mode. So they will automatically get the IE 7 standards. Applications that explicitly check for MSIE 7.0 and fail might actually behave differently and may actually not render properly because of this problem. However, the compatibility mode will help users get around it. There are a lot of interesting details around IE 7 that will help you mitigate this problem. If an application is hosting the Trident or the MSIE control, in that case, IE 7 is going to be the standard again. So let me show you a quick demo of how IE 8 looks like and how a developer can take control of how the website can be rendered for them. So I have two websites open here, CNN.com and Microsoft.com. And I'll show you how the two of them can control their own rendering in IE 7. If you go to CNN.com, you'll see at the top here as a compatibility view button. What does this button do? It allows the end user to click on it and say that the website runs in a compatibility view. I'll show you more when you view the source on this one. You will see that if you look at the doc type and the content and the meta tags here, you will not see any reference to any of the IE 8 compatibility modes. There are three ways you can set compatibility mode in IE 8 and take the control back into your hands. One is making sure that your doc type is strictly it is on a strict standard. Secondly, you can use the meta tag and the content tag to ensure that you're doing an IE 7 emulation mode. I'll show you in another site for the same thing. So if I go to the Microsoft's main website and show you the source for the same thing, you'll notice that the Microsoft website clearly has the content here, which says emulate IE 7. What does this mean? This means that the Microsoft website actually does not get the button where the users can switch between a compatibility view or not. So the website or the web page can take control of whether you want to see the user, whether the user can see this in a compatibility mode or in an IE standards mode. All right. With that, let me get back to the presentation, and we'll talk next about the next topic for IE8. IE8 has, by default, the data execution prevention on. This is nothing new. This has been around for a long time, except that this time it's on by default. However, this is on by default only for the latest service packs that are coming out for all the operating systems. Notice that one of the things that can happen with this is that applications that are not aware of NX can actually fail and crash Internet Explorer. One of the things that obviously needs to go through here is that applications and add-ons need to be compiled using DEP compliant frameworks. What that does is ensures that these add-ons will be able to handle no execute clearly and be able to have a really great user experience when users are using your add-ons. All right, let me switch to the next topic, which is UAC. For all of you who are aware of UAC from Vista, this is not a new thing. This has been around for a while now, and there's a lot of evangelism, education, and white papers available on how to get your applications moved from XP to Vista. So for those of you who are not aware of what UAC is essentially a feature that started with Vista, where applications by default run in a standard user mode. What do I mean by that? Essentially, applications and users, when they log in for the first time, they get a much lower level of privilege and integrity level that the applications can run in, and in a more protected environment. What this helps do is protect the users and their data from malware and various other negative security threats. And at the same time, it also causes a major compatibility break in the sense that applications that are not designed to work in a standard user mode are applications that check to see if their administrator can tend to fail. I'll show you some of the things that happens because of this. Here's a really old application that I have that is working on Windows 7 right now. One of the restrictions with UAC that you have is that you cannot write to various protected system folders, such as program files, System32 folders in Windows, and you can also not send messages between multiple levels of applications. If an application is running as a full administrator and another application running as a standard user, send messages between the two will not work. Of course, there's one more point to this, which is creating objects, session objects or global objects. An application that is running as a standard user cannot create global objects. However, they can create local objects. We have built a lot of things to mitigate these problems. The first of them is file and registry redirection. I'll show you one of them here. So this application is running as standard user. However, when I write to program files, it'll say the log is available. But if I go look at the logs, you'll notice that under C program files, that particular application or that particular folder doesn't even exist. If I look at Microsoft Windows Vista, that folder doesn't even exist. However, that particular file write has been redirected to a virtualized location. I can go to the virtualized location, which is under a new folder called app data. You'll notice that there's a program files folder here, and there's a Windows readiness folder here, and the log is actually written to the redirected file. You'll notice that the entry from this morning's is available. So what does that mean? That means that when applications running a standard user write to privileged environments, privileged folders, those writes are redirected, and at the same time, when the application tries to read it back, it will get the virtualized file from the redirected folder. Again, if I just do a check for administrator, I'm not an administrator running this particular application. Again, when I try to create a global object, obviously I cannot create one. However, if I try to create a local object, I can create fine without any problem. So these are some of the things with UAC that come into the picture. What can you do to take control of this situation as a developer? The first thing you can do is make sure you're compliant with UAC and update your manifest and update your application. I'll show you more details around the manifest later on. But now, let me show you another application here, which is UAC compliant. So when this application is compliant with UAC, you'll notice that it tries to change ACLs on a certain program files folder. It'll get access denied because this application is actually running as a standard user. The next one, I try to write to root, which is the C drive. Again, there's no access because this application knows about all the various parts about UAC, and applications that declare themselves to know and know that they can run in a Windows Vista or Windows 7 environment will actually not get any of the file and registry redirection. What this does is helps applications behave properly and get the right kind of behavior under the declarations that they've made in their manifest and how they've written their applications. All right, so what is new in Windows 7 for UAC? Well, the only new thing is standardized dialogues, making sure that the program name, publisher, and origin are all clear. There is no impact to applications for applications that are already designed for Vista. The only change is in some of the user experiences that the user will go through. There are multiple levels of settings now in UAC, and you can read more about it in detail in the Application Quality Cookbook, which has more details around it. And I've already talked to the rest of the things. But the key point here is that if you have an application that is designed for XP, you still need to bring it up to Windows Vista architecture, and that is still a requirement. And if you get it to Windows Vista architecture, it's a pretty clear path from there, which very little minor update to get it to work on Windows 7, or potentially no changes needed. All right, the next topic of guidance here is DPI. There are some interesting changes for DPI, very exciting ones for the end users. And that is DPI is a per user setting now, with no reboots required. However, a log on and a log off and a log on is required. If an end user or an administrator upgrades a machine from Vista, all the settings are maintained as in Vista. However, on a clean install, there's a new logic that determines what the DPI is going to be. The logic goes this way. If the hardware monitor and the driver that supports it support higher DPI automatically, then Windows will scale the DPI to 125%, or to what the driver and the monitor support. This means that there's a small percentage of people who will see a higher DPI by default. So what does this mean to you as a developer? This means that you really have to test your applications to make sure that they have the DPI and they work well with the higher DPI at 125%. This also means that it is really good, a great opportunity to take time to declare your application as DPI aware. I'll talk about the manifest in the manifest section when I talk about it later. So these are the key things to take away for this topic. Finally, there is something called file library. What is file library? It is a view that a user gets across multiple folders on the machine. So the users can create a library which can view various folders, whether it's on the local machine or on a network share. And it's also going to be the default save location for applications now that use the standard APIs for save and open. Note that library is actually a file. It's not a folder, because of which you cannot do path manipulations on them. However, applications can create their own libraries and use them as any other previous mechanisms. There are a lot of information around what APIs to use, how to manage all of those things. And again, I will redirect everybody to the Application Quality Cookbook, which has the granular details around how to get all of these things working. Last but not least, Windows Server 2008 R2. What does this R2 mean? There are a couple of interesting things here. 32-bit server doesn't exist for R2. It's 64-bit only. There are a lot of white papers available on Hyper-V, which is supported on Windows Server 2008 R2. A lot of interesting changes for Windows on Windows for 64, which is optional now on Server Core. And terminal services has a lot of enhanced features which will help end users and IT administrators allow running user client apps on servers running terminal services. All right, with that in mind, I close a chapter on the Windows 7 portion of it. Now I'm going to move and talk a little bit about how do you get your applications designed in such a way that you go beyond just Windows 7 or just one operating system and make sure that this works across multiple operating systems as new operating systems, Windows, comes out. The first topic on this is systems usage. So there are two major areas here. One is how do you manage the registry? Two, how do you manage system paths? And I'll talk to both of them. In our testing, we find that many applications use the registry as a communicating device between multiple processes. That's really not a recommended way to do. Use a COM server if you need to. There are more details available on how to do all of those kind of things. If you are interested, you can contact us, or you can really go to the cookbook and get that information. This is ready for that. If you're changing machine configurations, change it in such a way that you use the API to do that instead of just changing the registry values directly. Registry values and locations can change over operating system releases, and that means that they can actually, the API will be able to handle it, whereas if the application doesn't handle it, then there's a problem with that. Next, system paths. What does system paths do? Applications hardcode C documents and settings, for example, on Windows XP. On Vista and Win7, documents and settings doesn't exist. What does this do to applications? Obviously, they will not work properly, and there's a potential for data loss for end users at that point. So the guidance here is use the right APIs and the environment variables that you need to get to the folders that you need, the files that you need, and the locations that you need. Other similar such guidance include system objects. When you're using Windows system objects, make sure that you don't take hard dependency on static text such as name and descriptions. Avoid patching, meaning there are a lot of applications that try to inject code through IAT and EAT into Windows binaries and Windows processes. And that generally is a very bad thing to do. It's not recommended, and there's, especially in cases where there are protected processes, you can bring down the entire system by doing that. So there are APIs and recommended ways to do that. I would advise that everybody get to know. If you really need to know and monitor the system, there are really good ways to do that and recommended ways to do that. Oh, last but not least, avoid app init DLLs. If you don't know what it is, don't worry about it. It's a good thing. If you know what it is, try your best to avoid it, because app init DLLs is, again, another security issue which can cause future problems with the application. The next topic is error codes. What does error codes mean? Every new feature in Windows, when an API changes on a new version, there's potential that there are new error codes added. So if an application is looking only for specific error codes, and when they check return results, that means that there's a large opportunity for the large potential for the application to actually fail. So you need to have a catch-all which will allow applications to handle new error codes gracefully. Use the failed and succeeded macros to verify your returns. And this seems like very really simple guidance, but you'll be surprised to know that there are many applications that don't do that. This is why I want to put this out there so that people know about it and start using it on a more regular basis. All right, installers. This is one of the areas of applications that people generally give very little importance to. Notice that installers are your first experience with end users and IT administrators. So this is the impact that they will get when they see it for the first time. So devote more resources to it. Manage installers in such a way that you know how to handle various scenarios. Per user versus per machine scenarios. Program files versus user-specified directories. Installs as an administrator versus a non-administrator. All of these scenarios that you need to be able to make decisions on and handle your installer properly. Lastly, repackaging applications. Applications such as, or distributables such as Windows MSIs or Windows packages can be distributed as is. However, if you open them up into the individual components or binaries and try to package them in your application, then your installer will fail. The reason is because Windows packages are installed through what is called a trusted installer, and you can get more details about it again by reading the white paper about it. But breaking them apart ensures that your application will not install. So don't repackage them at all. And keep in mind that for the next version of Windows, 64-bit is going to be a big push, because of which if you still use 16-bit applications or 16-bit stub installers, they will actually not work on 64-bit operating systems. So you need to be able to get up to speed on both of them. That means that get your installers at least 32-bit so that they work on the 64-bit machines. Now I'm going to talk about probably one of the most important topics that developers need to be concerned about. Why should they be concerned, and why should they be excited actually about this, is that this is the one authoritative way where you can take complete control of the application and the user experience around that application, and make sure that Windows or the user has the exact behavior that you intended them to have. What do I mean by that? Declaring what your application is supposed to be and what the settings are supposed to be using the application manifest is the best way to make sure that Windows exactly positions that application in the way you want it to be. The first topic on that is, again, the UAC integrity level. Make sure that you know exactly what integrity level you want to run your application in. If you want to run it as a standard user, test it, make sure everything works, and make sure you declare it in your application manifest. It's a very, very simple line of code that you can add here that will just say, all you have to do is add the requested execution level. And as invoker essentially means that the application runs in the same privilege as the parent process that launched it. So that's one example that I have here. The second part about the application manifest, for Windows 7, we have introduced a new section called the compatibility info. What does this do? Basically, this is the part where you can decide whether you want the legacy behavior for your application or the new Windows 7 behavior for certain APIs. So here you can declare what OS IDs you support. Suppose you have tested your application on Windows 7 and you want all the latest behaviors. You can add your supported OS ID to be the Windows 7 GUID. When you add that, Windows 7 knows that this app works and with all the known changes in behavior, and it will give it all the latest behaviors on those applications. If an application is missing this section of the manifest, the APIs that have the behavior management will all give it legacy or Windows Vista behavior for those applications. So these GUIDs are going to be, again, available through the cookbook and other white papers online. So you should be able to find this on MSDN pretty soon. Last part of the application manifest is DPI awareness. This is a very simple change, again, a one-line change that you can do. Test your applications to make sure that they are high DPI aware, and add that one line which says that you are DPI aware. This essentially concludes the application manifest part of the talk. So from this point, I'm going to talk to you about some of the really cool and exciting tools that are available for developers to go get more information about their applications. The first thing I'm going to talk about is obviously the ISV Developer Portal. This is an absolute fantastic site and wealth of information for developers. What does this do? It gives you a lot of information around your application, the usage from end users, and you can go use the reports, and it's all free. That's the best part. You can, in fact, customize your applications to collect extra data points around Windows error reporting and get more information as you need them to be. You can customize more. So the homepage is wincall.microsoft.com, and I would really encourage you to use that in a really big way. Next, partner outreach. I've already talked a little bit about this. What we do in the application compatibility team is work with various enterprises and ISVs and work with them. We send them free Microsoft consultants. There is some criteria to get into this partner outreach, but once you're in, what you're getting is basically free consultancy from Microsoft to make sure that we can debug your applications, help you design your applications, and come up to speed, and make sure that you're working on Windows 7. If you want to contact us, here's the email address that's available for you. With that in mind, I'm going to talk about the resources again that I just talked earlier. Again, the Compatibility Quality Cookbook is really the one-stop source for compatibility for you. You can go there, get detailed information about all the topics that I discussed today and branch off to even more detailed white papers around it. devreadiness.org, again, is a really cool developer-centric site where you can go and get a lot of resources around the quality for Windows. And tools. Of course, there are many tools that are available. Obviously, the two that I'm going to touch on here is Application Verifier and Windows Error Reporting. Application Verifier is basically a tool that helps you catch a lot of bugs on your application while you're developing it. It is one of the requirements for Logo, so I would encourage you to use it and build your application in such a way that you're compliant with many of the Application Verifier rules. Obviously, I've already talked about Windows Error Reporting and the advantages of using that. With that, I'd like to conclude my talk today. Thank you very much for taking time to sit through this presentation. I hope you have a great time watching all the exciting presentations at PDC. And I'd like you to once again say, take the opportunity to read the Application Quality Cookbook and get your applications compatible with Windows 7. Thank you very much.